Welcome to this video lesson, which is the full solution to the practice questions of lesson 17, which covers the intersection between lines. This question is in two parts, and it's asking us to determine the relationship between A, these two lines, and B, these two lines. So for part A of the question, first let's check to see if the lines are parallel or not. To check if they're parallel or not, we are going to look at the two direction vectors, and we're going to see if one is a scalar multiplication of another. So is B1 equal to K multiplied by KB2? B1 is 1, -1, and 2, and we're checking to see if that's equal to K multiplied by 3, -2, and 1. That means 1 should equal to 3K. That's coming from the first set. And then we got the second, the y value, and we got the z as well. So we got -1 is equal to -2k, and we got 2 is equal to k. We can see that k value is different for each one. K is equal to 1 over 3 for this first one, k is equal to 1 over 2 for the next one, and k is equal to 2 for the third one. So for sure they are not parallel. We can also check to see if they're perpendicular or not right away, or we can just find their angle using the formula that we derived in the last lesson. But it's quick to check to see if they are perpendicular or not. All we have to do is to check the dot product of the two. So B1, the dot product of B1 and B2, they are 1, -1, 2, and 3, -2, and 1. To find the dot product, we will multiply the x components together. That's 1 times 3, that's 3. And then we'll add it to the y components multiplied by each other. That's -1 times -2, which is 2. And then the z components, which is 2 times 1, which is 2. And this is equal to 7, which is not equal to 0. Therefore, they are not perpendicular either, because their dot product needs to be 0 in order for them to have in order for them to be perpendicular. Now let's see if they have a point of intersection. To check to see if they have a point of intersection, we are going to use the x, y, and z components of them. So x, y, and z here. For the x components, x for R1 is equal to 1 plus t times 1, which is just t. And for R2, it's equal to 2 plus lambda times 3, which is 3 lambda. For y, it is equal to 2 plus t times -1. And for R2, it's equal to 3 plus -2 times lambda. And for z, it's equal to 3 plus 2t for the first line, and for the second line, it is -5 plus 1 times lambda, which is just lambda. What we want to do next is to rearrange this sides of the equations, and then use two of the equations to find lambda and t. So I'll do an example one here so you can kind of see. So I have 1 plus t is equal to 2 plus 3 lambda. I want to bring t and lambda to the same side, so I'm going to subtract both sides by 3 lambda, and I'll have t minus 3 lambda 1 plus is equal to 2, and I will get rid of the 1 by subtracting both sides by 1 to get t minus 3 lambda is equal to 1. So that would be my first equation here. So that's t minus 3 lambda is equal to 1. For the next equation, I want, okay, what should I do? I'll bring the t, the negative t, I'll add t to both sides to get a positive t. So I will have t minus 2 lambda is equal to, so I've brought the t to this side by adding t to both sides. And I'm going to subtract 3 from both sides to bring it to this side. So I'll get 2 minus 3 is equal to -1. And finally, for the last one, I have 2t. I'm going to subtract both sides by lambda here to get 2t minus lambda, and that's going to equal 2. I am going to subtract 3 by both sides to get negative 8. Once we have this, we can use two of the equations to find t and lambda. So let's call this equation 1 and this equation 2. I'm going to write both of them down here. T minus 3 lambda is equal to 1, and t minus 2 lambda is equal to negative 1. I'm going to subtract both of them, and the t's cancel here, and then I will have negative 3 lambda minus negative 2 lambda, and that's same as negative 3 lambda plus 2 lambda, which will give me negative lambda. And on this side, I have 1 minus negative 1, that's 1 plus 1, which is equal to 2. Meaning that lambda, if I multiply both sides by negative 1, is equal to negative 2. I can use that, so sub lambda is equal to 2, or negative 2, into, let's put it into, it doesn't really make a difference, let's put it into equation 2. So I will have t minus 2 times negative 2 is equal to negative 1. That's t. Negative 2 times negative 2 is positive 4 is equal to negative 1. Subtract both sides by 4 and we will get negative 5 for my t. Since I used equation 2 to find this, I can always go back and sub it into equation 1 just to check to see if my lambda and t values are correct. So if I were to sub this back into equation number 1, I would get t is equal to negative 5 minus 3 times negative 2, which is plus 6. So negative 5 plus 6 does equal to 1. So these two values are correct. Once we have these, then we need to make sure that the t and the lambda value is also consistent for this, for the third equation. So I'm going to put 3 here, and the left-hand side of 3 is equal to 2 multiplied by our t value, which is negative 5, minus lambda, which is negative 2. So we get negative 10 plus 2, which is equal to negative 8, which is same as a right-hand side. And since that's the case, that means for lambda value of negative 2 and t value of negative 5, we will get a consistent value for x, y, and z for both R1 and R2, meaning that they do have an intersection, or they're intersecting when lambda is equal to negative 2 and t is equal to negative 5. This is wonderful because now we can find the point of intersection, and what we are going to use, we can either use, it doesn't really make a difference, we can use this set of equations from R1, or we can use this set of equations from R2. The numbers here are a little bit lower in terms of value. These ones have 5s and the 3s, and these ones are mostly 2s and 1s. So we're going to use the right-hand side, the left-hand side over here, or equation from R1. So the x value is going to be 1 plus t, and that's 1 plus negative 5, and that's going to equal to negative 4. My y value is going to be 2 minus t, that's 2 minus negative 5, and that's same as 2 plus 5, which is 7, and our z value is 3 plus 2t, which is 3 plus 2 times negative 5. So that's 3 minus 10, which is going to equal to negative 7. And once again, I want to emphasize that if you did put in a lambda value of negative 2 here, you would get the exact same thing. 2 plus 3 times negative 2, that's 2 minus 6, which is negative 4. 3 minus 2 times, this 2 times negative 2 is negative 4, so that's 3 plus 4, which is 7. and we get -5 plus -2, which is -7. So in this case, the lines intersect at points which has coordinates -4, 7, and -7 for its x, y, and z coordinates. For the second part of the question, we're going to use the same procedure. So we're going to start with labeling the direction vectors, b1 and b2. And let's see if they're parallel. So is b1 equal to k times b2? So we got 1, 2, and -3 equal to k multiplied by -2, 1, 1. And to label things, this is our first one, and this is our second one. And because of this, we're going to use the x, y, and z coordinates. So for x, we got 1 is equal to -2k. For y, 2 is equal to k. And for last one, we got -3 is equal to k. Let's do each one. K is equal to -1/2. K is equal to 2. K is equal to -3. So therefore, they're definitely not parallel. Let's check to see if they're perpendicular. We don't always have to do this check to figure out if they're skew or if they're coincident or parallel, but sometimes it is nice. So we're just going to check to the dot product of b1 and b2. b1 is 1, 2, -3, and b2 is -2, 1, 1. Taking the dot product, we get 1 times -2 is -2, plus 2 times 1 is 2, plus -3 times 1 is -3. These two cancel out, we're left with -3, so it's not perpendicular either. Let's check for point of intersection. So we're going to use the x values, we're going to use the y values, and we are going to use the z values. For x, x1 is equal to 2 plus t times 1, which is t. And for r2 or x2, it is equal to -1 plus lambda times -2, so that's -2 lambda. For y, y1 is equal to -1 plus t times 2, which is 2t, which is equal to 1 times lambda times 1, which is 1 plus lambda. For z, we're going to have 0 plus -3 times t, so that's just -3t, and that's going to equal to 2 plus lambda times 1, which is just lambda. Now that we have this, we're going to rearrange these. I will do the first example here to show you the procedure. We got 2 plus t is equal to -1 minus 2 lambda. I am going to add 2 lambda to both sides to get rid of the 2 lambda on the right hand side. So I will get 2 plus t plus 2 lambda is equal to -1, and I am going to subtract both sides by -2 in order to write it as t plus 2 lambda is equal to -1 minus 2, which is -3. Once I have my variables in the left-hand side and I have my constant on the right-hand side, I can write the rearranged form. So I get t plus 2 lambda is equal to -3 for the first one. For the second one, I have 2t. I'm going to subtract both sides by lambda. And for the right-hand side, I'm going to add 1 to both sides to get 2. For the last one here, I pretty much have lambda on the right-hand side. I'm going to add 3t to both sides. I do like it to be positive. You don't have to have it as positive. Plus lambda. I'm going to subtract 2 by both sides to get -2. Alternatively, you could have just subtracted lambda from both sides to get -3t minus lambda is equal to +2. Both of them would be correct. Now I'm going to label these equations as 1, 2, and 3. And basically you can use any of these equations to figure out the values. And in this case, I don't have to multiply these two by anything, and I can just add them to get rid of the lambda. So that would be the easiest one to start with. So I'm going to highlight these two to indicate that I'm using them. So I will have 2t minus lambda is equal to 2. That's our equation 2. And 3t plus lambda is equal to negative 2. If I add the 2, I will get 5t is equal to 0 and t is equal to 0. And if I plug sub t is equal to 0 into either 1 or 2, it doesn't really, either 2 or 3, let's sub it into 2, I will get 2 times 0 minus lambda is equal to 2, so lambda is equal to negative 2. And these are the two values for t and lambda. So now what we're going to do is we're going to test to see if those values are consistent for the first equation as well. So our first equation, check for equation 1. So the left-hand side of that equation says that it's equal to t plus 2 lambda. The t value that we found was 0. And our lambda value was negative 2. So this will give us negative 4. Our right-hand side here is equal to negative 3, so these are not equal. And since in this case the left side does not equal to right side, that means that the lambda value, which is equal to 2, and the t value that is equal to 0, works nicely for the for the y and the z coordinates, but it's not consistent for the x coordinates here. So therefore, since we know that they're not parallel and they're not intersecting, therefore, so this means that therefore not intersecting. And since they're not parallel and not intersecting, therefore the lines are skew.